is not of the form y equals to mx plus c. So we need to change it to y equals to mx plus c before we can look at it and say, oh, the coefficient of x is the gradient and the constant term is the y-intercept. So to change this into y equals to mx plus c, we are trying to make y the subject. So as usual, we divide this into our left hand side and our right hand side. I want only the y term on the left hand side. I need to get rid of 2x, I need to get rid of negative 1. What do you want to get rid of first? The 2x or the negative 1? It's really up to you. You want to get rid of 2x first? Sure. How do we get rid of 2x? Minus 2x on both sides. Whatever you do on one side, you have to do on the other side for them to remain equal. So taking away 2x on both sides, we get y. You remove the 2x already, minus 1 equals to 0 minus 2x, so negative 2x. This is the reason why some of you may have heard other people say this. Oh, bring the 2x to the other side. I bring it over, then I change the sign. Bring over and change the sign. Who has heard this before? From your friends, from your tutor, from your parents, from your siblings. You bring to the other side, then you change the sign. Yeah, very common. Very easy to remember also. But do you know why? You have to know why. And this is the reason why. Because we are subtracting 2x on both sides. One reason why I don't like to say you bring to the other side, then you change the sign, is because, give you another example, x over 2 equals to 3, for example. You bring the 2 to the other side, then what does that mean? Well, am I supposed to bring it over and change the sign? You see, if I want the x value, how do you bring it there? Should you minus or plus and then you change sign? I don't know. So what we should be saying over here is that I multiply by 2 on both sides to give me 6. Whatever you do on one side, you do on the other side. Okay? So now that we have y minus 1 is negative 2x, I don't want the negative 1. So what must I do to both sides? Plus 1. So we have y equals to negative 2x plus 1. Okay, or if you know what you are doing, minus 1, bring to the other side, change sign, become plus 1. Which I totally don't like it. Okay, so now we have the form y equals to mx plus c. State the gradient. When they ask you to state, it means that it can be done very easily. No need a lot of working. Seriously, is there a lot of working over here? Alright, so what is the gradient? Gradient, negative 2. State the coordinates of the y-intercept of the graph. Okay, so coordinates. There are two things, x coordinate and y coordinate. The format for your answer will look like this, bracket, comma, bracket. There are two blanks over here. You need to state the coordinates. So what are the coordinates? Y-intercept, the y-axis, x-axis, okay, like this. This graph is sloping down, right? See, it's sloping down, it passes through 1. Passes through 1, slopes down. This is the graph. Label y equals to negative 2x plus 1. So this is the y-intercept. What are the coordinates? What is the x value over here? Go down. What block is this? Block 0. What level is this? 1. The y-intercept always has x coordinate 0. It is always 0, comma something. Okay, as shown in this graph over here. The first coordinate, what is it? X or y? It is always x. They are telling you x equals to 0. Let's put x equals to 0 into the equation. Y plus 2 times 0 minus 1 equals to 0. So y minus 1 equals to 0. Y equals to 1. That's the y-intercept. Next, find the value of y when x equals to 2. Do you want to plot the graph and find out? Or can we do it some other way? can do it in a much easier way, because plotting a graph will take you a long time, and the worst thing is that your answer may not be accurate, right? So they are telling us x equals to 2. What is the corresponding value of y? What should we do? What can I do with this x equals to 2? Actually, what are the options? What can we possibly do? I've got an equation, y plus 2x minus 1 equals to 0. This is an equivalent equation. It is the same equation, y equals to negative 2x plus 1. They want the value of y. They tell you the value of x. What can we do? Okay, if you're shy to answer, right, how about you tell me what is the value of y? I see whether you guys can do it mentally. So what's the value of y? When x equals to 2. Don't know? Negative 3? Anybody got negative 3? Raise your hand, negative 3. At least I know that you guys are thinking, yes, negative 3. But how? You substituted it here, right? Whether you substitute here or you substitute it here, you will still get y equals to negative 2 times 2 minus, plus 1. Negative 4 plus 1, negative 3. Done. Now exercise 7. Let's do it together. Write down the equation of the straight line. What is the format for the equation of a straight line, Harry? Y equals mx plus c. Yeah, Sean has already given us that. So, m is the gradient. They tell us it is 1. C is the y-intercept. And over here they tell us it is 4. So can you tell me the equation of this straight line? Y equals to 1x plus 4. Are you happy with this? Happy with this? Why not? What's wrong? That 1 over there looks really weird. It looks very out of place. Do we need to write this 1? No need. It is simply y equals to x plus 4. Okay? Now based on this, the question didn't ask for this, but can you help me do a quick sketch at the side? What does it look like? So start with your y-axis, x-axis. Do a quick sketch. No need ruler. 2 seconds. Sketch quickly. Finished? Is this what you have? A straight line going upwards from left to right is going up, and it cuts at the y-axis at positive 4. Do you have that? Okay, done. Okay, next one. Gradient of a straight line is 1/3, y-intercept is 4. So what is the equation? Y equals to x over 3, or you can say 1/3 x plus 4. Okay, either you write x over 3 or 1/3 x. For this particular topic, I would prefer to write it as 1/3 x, because I can compare very quickly and see, oh, 1/3 is the gradient. Rather than you write x over 3, then I have to, mentally bring aside the over 3 to become 1/3. Okay, so again over here, do a quick sketch. It's less steep this time. Okay, this gradient is 1/3 compared to the first gradient, which is 1, so I deliberately draw it less steep. Y, x, and this is 1 over 3. Part C and part D, please do it now. Can you help us with part C? -1, yes. So your graph has to slope down because the gradient is negative, and it has to pass through -1. So it has to look like this. -1, y equals to -2/3 x minus 1. Okay, good. Si Ting, can you help us with part D? 7 over 5 minus 2. So you notice that she changed negative 1 and 2/5 to become negative 7 over 5. Okay, so this is the correct presentation. We should avoid using mixed fractions in algebra. Leave it as improper fraction. So here we have again sloping down, a line sloping down, passing through negative 2. Y is negative 7 over 5, x minus 2. Okay, next page. Now we come to more details about gradient. So far what we have learned about gradient is positive gradient slope up, the bigger the value, the steeper it is. Gradient of 0 means it is flat, it is horizontal. Negative gradient means it slopes down. So all shown on the board. But is there a way to calculate the gradient? So yes, there is. In fact, there are 3 ways you can calculate the gradient. Okay, I will start off with what I feel is the easiest way to calculate the gradient. It is known as rise over run. Okay, so this is all these 3 of them calculations. They are all fractions. Something divided by something. So I'll start with this rise over run. How to remember? You have to rise up from your bed, then you can run. It's just a way to remember. Not much logic involved for this particular case. Okay, rise up from a bed, then you can run. Can you run then wake up? Unless you run in your sleep, but that's not what we're talking about here. So you have to rise, then you run. Okay, all remember already? Simple. Okay, done. Then now we need to talk about rise from where to where. Right? Okay, so let us take a look at an example. Okay, no, I think we can do this first. Later we talk about the calculation. I think we are already equipped to answer all these questions. Okay, positive, negative, so on and so forth. Let's do it quickly. Part A, positive or negative? Positive. Next one, negative. Okay, so you can use short form like this, minus VE or plus VE. Positive, negative. Next one, positive. Next, 0. Next, positive. And finally, undefined. Okay, so this is without any calculations. But you have an idea of what the value is. Next page. Do you need more time? Can I move on? Jermaine, okay? Next. Here is the calculation. I'll put it over here. Gradient equals to rise over run. For easy reference. For a straight line, for any straight line, the gradient is calculated by rise over run. The word rise means to go from bottom to top. Do you agree? Rise has to be from bottom to top. It cannot go from top to bottom and call it rise. Okay, so here, to go from bottom to top, you see they gave you 2 points, point A and point B. Which one is at the bottom? B. So we must go from B to A. Now, rise, this rise over here means vertically up. Okay, so vertically up from B to A. I'm going to go up. Help me count. How many units? 1, 2, 3, 4. Should I stop here? Yes, I should stop here. Okay, I rise up by 4 units up. Right, this is what I did. After I rise up, okay, since you guys are writing, then this is just 4 over. Simple enough? That's the rise, huh? What about the run? Running on the horizontal ground, on flat ground. Do we run to the right or to the left? We are going to run to the right. How many units do we run? 1, 2, 3. 3 units to the right. Do you think you have the answer already? Yes, this is it. This is the gradient. Simple. Now check. Is your calculation a positive number? Does it tally with the graph? Yes. That's it, gradient. Let's try with part B. Okay, we have to find the point that is at the bottom because we have to rise first, isn't it? Gradient is rise over run. So this is at the bottom. They identified the point for us. So we're going to rise up. Can you help me count? How many units up? Are you going to fall into the trap? Is it 6 or 3? 6 units up. Because look, every square is 2 units upwards. So you have to be very careful. 6 over, and then we run to the right. 1, 2, 3, 4. 6 over 4, which is 3 over 2. Okay? If this is positive, it's sloping upwards. So it makes sense. Let's go down to D. Let's do D first. Gradient is rise over run, yeah? Okay, so rise from the bottom. Where are the 2 points? Did they indicate for you? Oh, they didn't. They only indicated 1 point over here. Do we get to choose which point we want to use? Or must we follow what they say? Let's try it out, okay? If we get to choose ourselves, let's choose this as one of the point. What other point will you choose? The left one. So Sean is going to choose this, right? Huh? Any other points that we can try? Can we try this also? Can, right? How about this? We all try different ones. However, this over here is sloping down. Our formula doesn't change. Rise over run. But wait. Listen first. Regardless whether you choose this as the bottom, then you rise up. Rising up is no problem. Rise 2 units over here. But we are going to be running to the left, right? No matter which point you choose. Suppose you choose this and this. They rise 4 units up. They're going to be running to the left. If you choose to start from here, you're going to rise up 2 units and then you run to the left. You see, you always run to the left. Here is the next rule that I haven't told you yet. The run has a sign. When you run to the right, just like the first 2 cases, it is positive. What do you think happens when you run to the left? It is negative. Yes, that's it. Okay, so please try for part D. Whether choose any of these points, any 2 of them, and you stick with it, and you calculate your gradient. Okay, 1, 2, 3. Choose 2 and calculate the gradient. How many different ways of calculating gradient do we have over here? I can choose AB, right? That's one way. I can choose BC. That's the second way. I can choose AC, correct? Let's start with AB. If I choose AB, my rise is 2 units. My run will be 1, 2, 3, negative 3. So this is negative 2 over 3. This is if I choose gradient AB. Okay? Now what if I choose gradient for AC? AC, so forget about point B. I'm going to rise 1, 2, 3, 4. Divided by, going to the left, so it's negative 1, 2, 3, 4, 5, 6. Negative 6, which is negative 2 over 3. Same. How about the last case, BC? Gradient BC, 2 over negative 3 again. Negative 2 over 3. So do we get to choose the points we want? Yes, you get to. In fact, in questions, the first 2 questions, they gave you the 2 points, right? If you do not follow their 2 points, you should still get the same answer for the gradient, because that's how it works. But there's a problem. If you do not choose these 2 points, A and B, what would you choose? Will you choose this point? Are we able to tell the exact coordinates? We can't tell exactly what this is. it is our grid over here is not precise enough. Okay, so when you look, you want to find a gradient, you have to be smart and choose points that you are confirmed, that you are sure are correct. Okay, so that will be intersection points over here. For your homework today, please find out the gradient for the remaining C, E, and F. Class 10.